Okay, welcome to step 5 of 6 in the force procedures. To recap, I have step 1 on the board. I don't know if you've noticed this, but the free body diagram seem to have shifted left. I've moved it back onto the screen. There is a little bit of thought here in getting being able to identify the forces, but you should know what the forces are in every problem. That should not really be an issue. You just have to pay attention to what's going on. Step 2 is no thought at all, just pick a positive direction. Step 3 is to create the force chart. Here, you already know how to do this. You have to find the components of the vectors and put them in the chart. Step 4, no problem whatsoever. Just add the columns up. Here, we're doing algebraically. Other times, you'll actually just have numbers and you get your calculator and do it. Okay, now, as hinted out in the last step, F net is half of the equation that we're looking for. The next step is going to be simply setting each of those columns equal to mass times acceleration. Okay. The left-hand column, again, is just symbolic. F net equals mass times acceleration is Newton's second law. That's actually a vector equation. It stands for two separate equations, one for x and one for y, and those are the two equations at the bottom of the second and third columns. Okay. So in the x component, we have m times ax, and the y component has m times ay. Now, as an aside, you can have many different forces acting on an object, but the object, if it is to remain a single object, the object can only have one acceleration. Okay, that acceleration, remember, is a vector, so it can have components in the x direction and y direction, but can only have one acceleration if it's going to remain a single object. Otherwise, it's going to break apart. Think of tar and feathering, for instance, or no, what you do is drawn and quartered after the tar and feathering, right? Where attach uh, um, the object of the drawn and quartered gets ripped apart. Okay, that's what happens when an object has more than one acceleration. It breaks apart. So we have, at this point, we haven't done a lot of thinking, right? The first step was to identify the forces. That's not a lot of thinking there. This is what you already know. You know the direction of force, or you know what forces are acting. You're being told it's being pushed. You're told that there's friction. It's on the earth, so it must be gravity or something like that. So you can identify the forces. Second step is just choose a positive direction. There's no thought involved in that. The third step was to find the components, and you already know how to find components. Fourth step was just add the columns. Here we set it equal to mass times acceleration. Here is the first time we actually have to think about what we're doing. Okay. Here we have a car that's moving along the x direction. It's not moving in the y direction. It's on the ground. 5 minutes later, it's still on the ground. Right. So the acceleration in the y direction is 0. Okay. That means that the x direction, the acceleration, is simply the total acceleration. There is no acceleration in the y direction. It's wholly in the x direction. Okay, so for this problem, ax is simply the acceleration, and ay is equal to 0. So for this type of problem, a car moving along a horizontal, then the acceleration in the y direction is going to be 0 because it's not moving up and down. And the acceleration is simply going to be in the x direction. Now, that acceleration may be 0, it may be positive, it may be negative, it might be whatever, right? If you're told that the car is moving down the street at a constant speed, then the acceleration is going to be 0, okay? And that is step 6. So at this point, we have 2 equations, okay? We haven't done a whole lot. Once you practice this a few times, the first place that you actually have to do some serious thinking is right at this point. What is the value of the acceleration that you put in? Typically, at least one is 0, right? Sometimes both are 0. That makes the equations easy to solve.